voltage tripler. It is just an extension to our voltage doubler. Okay, in voltage doubler, what we did, what happened? We took a negative clamper followed by a positive clamper. Okay, two diodes we used and two capacitors. Here we applied Vm sin omega t as input. Then once this diode D1 is on, it will charge to a voltage Vm with polarities like this, and D2, once it is on, the current will be going in anti-clockwise direction. It will charge up to 2 Vm, we have seen. Output is taken from bottom to top. Okay, so here what happens is, to have a double the peak amplitude of the input, we used two diodes and two capacitors. Now voltage tripler means it produces a DC voltage whose amplitude is twice the peak amplitude of the input AC signal. That's it. Input has a peak amplitude Vm and output is having 3 times the peak amplitude of the input. Okay, and here I have drawn the circuit along with some voltage polarities. Now how it is coming, let us see. Okay, two ways we can take the circuit. Here voltage doubler, what I said, first we started with a negative clamper. This combination, negative clamper D1 acts as negative clamper, next D2 acts as positive clamper. Ulta is also possible. We can take positive clamper first, next negative clamper. So both ways, voltage doubler, two circuits I draw. Here also we can see two combinations of voltage tripler. Not only this, another one is something this way. Okay, what is this circuit and all? Right, we can use either this circuit or this circuit for voltage tripler. Okay, if I take this circuit, input is Vm sin omega t, and here it will charge up to Vm with polarities, and here if this diode is on, current will flow like this, plus minus it is 2 Vm, and if the diode is on here, it is 2 Vm. So this is our overall output taken from right to left. Input is this way. This is also another circuit. We can take either this way or this way. Let us have a look at the operation of these circuits. Okay, see this. The first one is with a negative clamper. First, we know the output of this one. If I give Vm sin omega t, then what is the output? Vd1, voltage across the diode dy1, or I can write Vo1. Okay, Vd1 only. It is, diode is downwards, it's a negative clamper, Vm sin omega t minus Vm. Okay, and this capacitor Vc1, capacitor 1, it is equal to Vm. Capacitor will charge up to Vm with polarities like this, whose output is given as input to. In voltage doubler, what we did, we give its output as input to a positive clamper. Okay, so positive clamper, what I am doing here is, this is what we took, so that this capacitor will charge up to 2 Vm with polarities, sorry, this way. We are well aware of it. Okay, now what I am doing is, just I am changing the positions, not the, right. So here what I am doing is, see this, here I am taking the capacitor and the diode is upwards. Okay, instead of taking diode here and capacitor here, I am just, it is in this loop, right, capacitor here and diode here I am taking. Okay, so that, what about voltage across the capacitor? The capacitor will charge. If the diode is on, current will flow like this, anti-clockwise direction. The capacitor will charge to 2 Vm. And it is the diode D1, capacitor C1, diode D2, capacitor C2. What about voltage across the diode D2? VD2 from cathode to anode, of course. VD2, it is equal to, it is like a positive, D2 acts like a positive clamper. VD2 is Vm sin omega t plus Vm, right? And if I take voltage across the capacitor C2, it is 2Vm voltage doubler circuit. Okay, done. Now, VD2 is acting as input to another negative clamper. Okay, Vm, see, here the capacitor C1 is charged to peak amplitude of the input Vm. Next, here it's a D1 acts like negative clamper, D2 acts like positive clamper. Here the capacitor will charge up to the negative peak of the input. What is the negative peak of the input? Vm sin omega t minus Vm. It is 2Vm. Is it not so? So C2 will charge up to Vc2 is equal to C2 will charge up to 2Vm. We are aware of it. Okay. Okay, here I am not writing it, not required also, nothing to worry. And what about VD2? It is V1 by Vm sin omega t plus Vm. It's a positive clamper. Now, whose output is given as input to again another negative clamper. Negative clamper means what? I can write negative clamper means this one. You see this combination, right? It is a negative clamper. So, to what level the capacitor will charge? Capacitor will charge up to the positive peak of the input signal. What is VD2? Vm sin omega t. What is its positive peak? Definitely 2 Vm. It will charge up to 2 Vm. Is it not so? And D3 and it is C3. Capacitor C3 VD3 is equal to Vm sin omega 3 minus Vm. Okay, and what about C3 Vc3? It is 2 Vm. That's it. Alternatively, see what we did here. If you observe this, here D1 negative clamper and C1 D1 negative clamper combination, C1 D1 combination. Next, whose output is given as input to another positive clamper. So its output is here, that is given as input to a positive clamper. Next, C2 D2, right? D2 output is acting as input to another negative clamper. So one negative clamper, positive clamper, again one more negative clamper. Alternatively, we are using. Okay, that's it. Now what is the final output? The final output we take here. Plus and minus. V output is, what is the voltage at this point with respect to this point? It is Vm plus 2Vm, total 3Vm. Is it not so? Okay, if you want you can write it. Anyway, VD3 I wrote there. It's a simple point actually. Okay, so Vc1 is Vm and Vc2 voltage across the capacitor C2, it is 2 Vm, and voltage across the capacitor C3 is also equal to 2 Vm. Only first capacitor has charged up to Vm, next two capacitors have charged up to 2 Vm. That's it. Overall output is equal to 3 Vm. Is it not so? See this. This is what I have drawn here. First capacitor C1 D1, right? It's a negative clamper. It is 1. It is a negative clamper. Next, C2 D2 combination is positive clamper. And third combination is one more negative clamper. Alternatively, Okay. And why I am mentioning clamper means because clamper output is taken across the diode. The voltage across diode is acting as input to positive clamper. Again, positive clamper output is taken across the diode D2, which is acting as input to another negative clamper. So very, very simple. Okay, so negative, positive, negative clampers. Or other words, we can start with positive clamper also. Okay, see this. First, let me start with positive clamper. Okay. So whose output is like this, input is Vm sine omega t. This capacitor, once the diode is on, the current flows in this direction. So this capacitor will charge up to Vm with polarities this way. And what about Vd1? Vd1 is equal to, diode is upwards, no? Vm sine omega t plus Vm. We are well aware of it. Whose output is given as input to a negative clamper. The only concern is it's a combination of generally negative clamper means what do you expect? This is what you expect. But don't use the capacitor here. In the same loop only, instead of using the capacitor there, I am using the capacitor here. First I am taking the diode, next the capacitor. That's it. Instead of taking the capacitor here, I am taking here. Okay. So this capacitor will, right, D2 C2 combination acts like a negative clamper. Voltage across D2, Vd2 is equal to Vm sine omega t minus Vm. And what about C2? C2 will charge up to the positive peak of its input. What is the input to this circuit? Here, output of voltage across D1. So Vc2 is equal to 2Vm. How about the polarities? Plus minus 2Vm. Because if the diode D2 is on, the current flows in clockwise direction. So voltage across the diode D2 is known. A negative clamper output is acting as input to positive clamper. Now here alternatively, see, one capacitor has come here, next capacitor is coming here, next capacitor has to come here. Positive clamper means diode is directed upwards. That's it. It is C3 D3. Vd3, voltage across diode D3 is equal to Vm sin omega t plus Vm. And C3 will charge up to the negative peak of the input. Okay, and of course the current will be flowing in this direction. It will charge up to 2Vm. Okay, now I can take the overall output between these two terminals. Now it is minus, it is plus, no, plus minus. Overall output is equal to, right, it is 2Vm plus Vm, it is 3Vm. That's it. See, in the earlier case, the output polarities are from left to right. Now, in this case, the output polarities are from right to left. That's it. That is the only difference. So, we can take the voltage tripler circuit either this way or this way. Both are correct. Okay, alternatively, we are taking the capacitors are, see, one diode is upward, the other diode is onwards, another upward, next, right, capacitors. One capacitor, first the regular circuit, next time the capacitor is taken here instead of here. Next capacitor is coming here. alternatively. Okay, this is how we can take it. And let us have a look at some simple problem on this voltage tripler circuit. Suppose I have suppose it is given 3 sin omega t. So find the output of the circuit. What is the answer? 3 times the peak amplitude, that is 9 volts. Okay. Generally what happens here, we can simply take the voltage polarities like this, plus minus, it is 3 volts, and here plus minus 6 volts, and here this polarities and 6 volts. So overall output is equal to 3 plus 6, anyway 9 volts. We can write it. Suppose in the same problem, if they mention the output polarities are to confuse us, they may give so. Same circuit only, 3 sin omega t only, and it is C1, D1, C2, D2, C3, D3. If they mention this is the output, polarities are given this way, then what should be your answer? Minus 9. We should be very careful how they are giving the polarities. That's why every time what we should do is we should take the polarities of the voltage. Here it is 3 volts. Just see the direction of the diode and how the polarities of the voltage across the capacitors, right? And it will go like this. So plus minus, it is 6 volts, and again here it is like this, plus minus 6 volts. Ultimately V output is equal to minus 9 volt. Okay, should be very careful. And there is another way of asking the question. Okay, suppose if okay, the same circuit only, it is 2 plus 3 sin omega t. Okay, and find the output. It is given polarities like this only. Then what is the output? Is it 9? No, it is 11 volts. Because see, if you take the first capacitor, how does it charge? This capacitor will charge up to the peak amplitude of the input. It will charge up to 5 volts. And VD1 remains as it is. VD1 is equal to, right, it is 3 sin omega t. Diode voltage does not change, negative clamper. And next here it is plus minus. If the diode is on, current will be going like this, and it will charge up to 6 volts. And next it is VD2 is equal to Vm sin or 3 sin omega t plus 3. So this capacitor will charge up to 6 volts only. So VD1, VD2 values does not change, but overall output is equal to 5 plus 6, 11 volts. This is one kind of trap. They have not yet asked, but you can just expect this kind of questions. Okay. Or they may give minus 2 plus 3 sin omega t. In that case, it will charge up to only 1 volt, and overall output is equal to 7 volts instead of 9 volts. Anything is possible. Okay, the students should be very careful in looking at this kind of questions. what are the polarities of the voltage they have mentioned, and what is the exact input they give. It's all. Once you understand the positive and negative clampers, just like that, we can analyze the circuits. Okay, now you see voltage quadrupler. So here output is a DC voltage whose amplitude is equal to 4 times the peak amplitude of the AC input. Okay, that's it. Input is Vm sin omega t, so output is equal to 4 Vm. It's a DC signal whose amplitude is equal to 4 times the peak amplitude. Okay, how does the circuit appear? See, up to here we have seen, is it not so? First, it is a negative clamper. So once the diode is on, the capacitor will charge up to Vm with polarities plus minus, whose output is acting as input to a positive clamper. Capacitor is taken here instead of here. So this capacitor, once this diode D2 is on, current will be going in anti-clockwise direction, and the capacitor C2 will charge up to 2 Vm. And voltage across diode D2 is Vm sin omega t Vm, which is acting as input to another negative clamper circuit. Is it not so? So alternatively, right, one diode is downwards, other is upwards, next downwards, next upwards, like this. One capacitor is at the top and one capacitor is at the bottom. One capacitor is at the top, next one more capacitor at the bottom. So D3 C3, C3 will be charging up to 2 Vm. And D3 output, diode is downwards, it is Vm sin omega t minus Vm, which is acting as input to a positive clamper. The only thing is, instead of taking the capacitor here, we are taking at the bottom. And hence this capacitor C4 will charge up to 2 Vm with polarities plus minus from left to right. How to choose it? So look at the diode. Diode is directed upwards. If the diode is on, current flows in anti-clockwise. So this is how we can choose. Okay, without C4 D4 combination, it is a voltage tripler. What we did? We added one more diode capacitor combination. See, voltage doubler, it has 2 diodes, 2 capacitors. Voltage tripler has 3 diodes, 3 capacitors. Voltage quadrupler has 4 diodes and 4 capacitors. That's it. It's as simple as that. Next, what about the output here? Output is taken at the bottom. Earlier, right, if I take this as output, or let me take it is VO3, voltage tripler. It is equal to 3 Vm. We studied this already. Now, what I am doing is coming downwards. Instead of upwards, I am coming downwards. So, from this point to this point, what is the overall voltage? 2 Vm plus 2 Vm, 4 Vm. That's the overall. It is called voltage quadrupler. Okay. Again, the same thing we can, the same circuit or the same result we can have using right, alternatively by changing the positions. So first let us start with positive clamper, next negative clamper. Positive clamper, negative clamper. That's how we can take it. Let us have a look at that circuit as well. I am starting with positive clamper. C1, D1, Vm sin omega t. Next, instead of taking the capacitor here, I have to take here. Downwards. And here, voltage across the diode D2. Okay. Let me take, it is VO1. And VO2. VO2, right, it is output of a negative clamper is given as input to positive clamper. Right, here alternatively in this part capacitor has come upwards, here the capacitor has come down, and here the capacitor has to go upwards. So positive clamper. Again, the output of positive clamper is acting as input to a negative clamper. So here I have to take the capacitor and negative clamper. this way. It is VO3. Okay, 4 diodes and 4 capacitors. Done. C2, C3, C4, D2, D3, D4. Alternatively, we are taking positive and negative clamper circuits. Now, coming to its working. C1 will charge up to, so how to find the polarities of voltage across C1? See, diode direction only, plus minus Vm. And what about C2, Vc2? It is plus minus 2 Vm. Next, this is done. Next, it is with polarities to Vm. Next, here, plus minus 2 Vm. Now, VO2 diode is directed upwards, no, positive clamper. VO1 and VO3 are positive clamper outputs, that is Vm sin omega t plus Vm. And VO2, VO4, I can write this as VO4. VO2 is equal to VO4 is equal to negative clampers Vm sin omega t minus Vm. That's it. Next, what is the overall output? Voltage quadrupler, I said no. So, minus VO4 is taken from this point to this point, right to left. It is 2 Vm plus 2 Vm. It is equal to 4 Vm. Overall output, I can say, not VO4, V output. That's it. There is no difficulty in it all. Generally, students get a lot of confusion in this voltage tripler, quadrupler, how to remember the circuit and all. It is dead easy actually. We did a lot of exercise, right? Starting from negative clamper, positive clamper, with or without reference voltages. Once you understand that, doubler circuits are very, very simple. Based on that, we can write tripler, quadrupler, etc. Okay. Based on that, now voltage multiplier, alright, instead of doubler, tripler, quadrupler, right, etc., I am writing voltage multiplier, generalized, right. So, I am starting with positive clamper. You can start with positive or negative clamper, anything. So, this is the output, which is acting as input to a negative clamper, and negative clamper output is acting as input to another positive clamper. Positive clamper output VO3, which is acting as input to negative clamper. The only thing is, negative clamper means diode is downwards. The capacitor, instead of taking here, I am taking the capacitor here. That is the only difference. VO4, voltage quadrupler, we know, right, 4 diodes, and C4, D4. Here capacitor and diode. Next, its output VO5. VO6, C6, C5, D5. Now we can easily understand its answer. Okay, the diagram has gone upwards. No, I have not written good. Okay. Vm sin omega t. This will charge up to Vm. Right? You know how to choose the polarities and all. This will charge up to Vm. Next, this will charge up to Vm. Next, this will charge up to 2 Vm. Next, this will charge up to 2 Vm. Next, this will charge up to 2 Vm. We can just see the direction of the current flow. There is nothing to mug up anything. Like this. Okay. Then let me take, or let me write these things as VO1 dash, VO2 dash, VO3 dash, VO4 dash, VO5 dash, VO6 dash. So VO1 dash is equal to VO3 dash is equal to VO5 dash. Like that you can connect. It is equal to, diodes are directed upwards, they are positive clampers. Vm sin omega t plus V1. VO2 dash is equal to VO3 dash is VO4 dash is equal to VO5 dash is equal to VO6 dash. These are all negative clampers. That's it. Now let me take this voltage as VO1. Right, I am taking from right to left. What is VO1? It is equal to Vm. Okay, next coming down, VO2, polarity is plus minus, its value is equal to 2Vm. Is it not so? Next VO3, go upstairs. 1, 2, 3, 4, up and down. We keep on moving. VO3 means it is, right, I am taking the polarities from right to left. What is this value? It is 2Vm plus Vm. It is 3Vm, voltage tripler. Next coming down, minus VO4. Here it is 2Vm, right to left, again right to left, it is 2Vm. It is 4Vm. Go upwards. VO5. Take from right to left. What do we get? 2Vm plus 2Vm plus Vm. It is equal to 5Vm. And coming downwards, right to left. So 2Vm, right, this voltage is 2Vm, again this voltage is 2Vm plus Vm. VO6 is equal to 6Vm. Like this we can take. Okay, this is known as voltage multiplier. Alternatively, positive negative clampers, or vice versa. We can start with a negative clamper, next positive clamper, negative clamper, positive clamper, etc. Then instead of taking the output from right to left, we will take the output from left to right. That's it. It is that much simple. Okay, I hope the students can draw that circuit. Negative clamper, next positive clamper. Oh, anyway, students can try this because it again takes, I have to write it in the middle. Alternatively, positive and negative clampers. Vm sin omega t. So plus minus Vm, here plus minus 2Vm, plus minus 2Vm, here plus minus 2Vm, plus minus 2Vm, plus minus 2Vm. D1, D2, C2, C3, D3, D4, C4, C5, D5, C6, D6. VO1 dash, VO2 dash, VO3 dash, VO4 dash. So we can write like this: VO1 dash is equal to VO3 dash is equal to VO5 dash is equal to so on. It is equal to Vm sin omega t minus Vm. Next, VO2 dash is equal to VO4 dash is equal to VO6 dash, etc. It is equal to Vm sin omega t plus Vm. And coming to the overall output, VO1, right, I am taking from right to left, and VO2 to Vm, right to left. Again, VO3 is equal to Vm plus Vm, 3 Vm plus minus. VO4 is equal to 4 Vm plus minus 5 Vm VO6 6 Vm. We can extend it like this. This is called voltage multiplier. Okay, they give more DC but with less currents. Current is almost 0 like that. Okay, that's it. Because in steady state all the diodes are off and the capacitor voltages are looking constants. Okay, and this is what we take for ideal cases. Practically there is a voltage drop of 0.7 from each stage. Okay, first to second stage 0.7 volts, second to third stage 1.4 volts, and third to fourth 2.1 volt, like that. The voltage drop will be there under ideal conditions only. It is true. Basic principle we are looking at. The basic principle of voltage multiplier we see. And the applications of voltage multipliers they are mainly used in CRTs, cathode ray tubes or cathode ray of oscilloscopes. Right? If you take CRO, cathode ray oscilloscope, in that the major heart of CRO is CRT. That one. Traveling wave tubes in microwave engineering, right? You studied what is meant by traveling wave tubes and etc. There also we use this kind of things. Laser systems. Actually, wherever you need CRT, right? These are all TWT, laser or X-ray, right? LCD background, right? Backlighting, all these things. They make use of this CRT, right? Which makes use of this voltage multiplier circuit. And power supplies, DC power supplies, right? Regulated power supplies we say, right? RPS or DC power supplies, and okay, particle accelerators like in bunching phenomena and all. No, we studied in TWT, right? Reflex cluster and all, right? There to accelerate the particles we use this CRTs, which make use of this voltage multipliers, ion pumps, etc. Okay, right? The same point only, it is repeated. Right? Let us now look at some problems. A sinusoidal signal Vm sin omega t is applied to the input terminal of a circuit and output is brought out from the indicated output terminal. Assume that the diodes to be ideal at steady state. Below circuit best represents. Okay, So it is, you see, we are well aware, right? It is a voltage, right? If you take plus minus, it will charge up to Vm, and next it will charge up to plus minus 2 Vm, next again plus minus 2 Vm, and here plus minus 2 Vm. So VO1 is equal to 3 Vm. It is voltage tripler. The output is taken from, right, VO1, then it is voltage tripler circuit. And VO2, it is equal to 4 Vm, okay, with negative sign. See, here we are getting the polarities from left to right, but it is given from right to left. Anyway, right, it is voltage quadruples circuit. Right, output is equal to minus 4 Vm, that is for sure. Okay, but it is voltage quadruples circuit. Next is this. Again, this is also having 4 diodes, 4 capacitors. It is voltage quadrupler circuit, no doubt about it. Okay, just to confuse us, they have drawn the circuit like this, nothing else. So here the first capacitor will charge up to Vm like this, and you see this is the second loop, and here to here we can take this capacitor will charge up to, because look at the direction of this diode, plus minus 2 Vm. Next, this part between these two we have to see. If the diode is on, the current will be going like this, so it will charge up to 2 Vm with polarities. D4, it will, the capacitor C4 will charge up to, okay, it will go in the direction of the diode. Always the current should be in the direction of the diode. So plus minus 2 Vm. So output is equal to 4 Vm from bottom to top, voltage quadrupler circuit. I am not redrawing it. If you redraw it, what the previous first one is negative clamper, right? Negative clamper followed by positive clamper, next again negative clamper, next positive clamper. We can even, students can even redraw it and try it. You will get back the what voltage quadrupler circuit we have taken already. That thing can be same. And see this question. Match list 1 circuits with list 2 characteristics or applications and select the correct answer using the code given below the lists. High pass circuit, right? High pass circuit acts as a differentiator, we know, right? Low pass circuit acts as integrator, high pass circuit acts as differentiator. Low pass circuit, integrator. And clamping circuit or a DC restorer. And a clipping circuit can also be used as a comparator. Another application of clipper is comparator, not compensated circuit. Okay, so A4 only, right, we can see, and B3 low pass circuit as integrator, B3, A4, B3, oh, okay, B and D, you see, A4, right, B3, even for D also you have that, and C clamper is DC restorer. Okay, so it is C is correct here also, and D clipping circuit or comparators. So this is correct. So all are correct for option D. D is the answer. That's it. Okay. Anyway, we will see later on how high pass circuit acts as a differentiator, low pass circuit acts as an integrator. Those things, right? A clippers as a comparator. Actually, that's not there in the GATE syllabus. It's from the BTech knowledge. We can, right, think of it and all, right? Clippers, it always compares the input with the reference voltage. Above reference voltage, right, it is not allowing, and below reference it is allowing, or vice versa is possible. That is one of the applications of the clipper circuit we can take. Okay, that's about the clampers.